Welcome to my presentation. We come from the Hong Kong Polytech University and Damo Academia of Alibaba Group. In the presentation, I will focus on two major issues for one-stage video instance segmentation: spatial feature calibration and temporal fusion. First, unlike array pooling or align in two-stage network, convolutional features of one-stage methods are neither aligned with anchor boxes nor with ground truth bounding boxes. This reduces the mask sensitivity of spatial location. No prize quiz. What are the objects in the pictures below, bears or earless seal? It's even difficult for humans to distinguish similar objects through local information. We design a feature calibration strategy for anchor box and ground truth bounding box to obtain more precise spatial features. On one hand, to enable each anchor box can extract its own specific features, we will first design multiple convolutional kernels at each spatial location, like 3 multiple 3, 3 multiple 5, 5 multiple 3, and then generate anchors according to the receptive field of these convolutional kernels. On the other hand, to improve feature presentation for objects segmentation and tracking branch, we first predict regressed bounding box around ground truth bounding box by regression branch, and then extract features from them to segment and track instance like the C. We provide two strategies for obtaining the size of deformable convolutions: a single one convolution layer called adaptive features, and mathematical derivation called aligned features. For most existing methods, a video is directly divided into individual frames for frame-level instance segmentation, ignoring the temporal correlation between adjacent frames. These methods fail to deal with challenging videos like motion blur, partial occultation, uncommon view, small objects, and so on. We introduce a temporal fusion module to one-stage methods. We first need to compute frame-level instance masks from frame t-1 and t individually. Then use the temporal fusion module to estimate instance masks from frame t-1 to frame t. And finally, merge frame-level and cross-frame masks by assigning instance IDs based on the matching circles of the embedded vectors in mask IOU. Here are the overview architecture of our proposed ST mask. Ablation study shows that spatial feature calibration and temporal fusion can bring significant performance improvements, of which temporal fusion module is the most obvious. 5.2% mask AP on YouTube VS validate. Quantitative performance comparison showed that effective one-stage methods, ST mask, does keep the balance between performance and speed. The visual comparison of mask results among soda methods demonstrates that on challenging videos, ST mask obtains better segmentation results in both spatial and temporal aspects.